Hello everyone, this is Diana Moraro, and together with my colleague Philip Gang, we would like to welcome you to the OS MasterMap Highways Roads webinar. We will go through a technical deep dive explanation of the Highways Roads product, its content and structure. So here we go. So I would like to start with initially with the sort of how the OS MasterMap Highways family is made up of three products: roads and routing and asset management, short for RAMI, and paths. Today's webinar will be focusing on the roads, as I just mentioned. You can see now on the screen as well the roads feature components listed. We will be talking today on each feature individually: road link, road node, road street, and so on. Again, this is a rerun of the webinars we had in December, and we will also have tomorrow and Monday the webinars for the other two products, RAMI and paths. As I said, today we will just focus on the roads. Also, I would like to mention that in the following slides, we will go into detail on each feature type and attribution. And it would be useful to have your technical product specification document in the front as well. This can be found attached to the webinar window, or if you need it at a later date, this can also be found on the OS Highways website, on the Highways support. So we will make reference to this document. Okay, so further on, I would like to start with the Highways model, with the general data model for this product. As you can see, we see the different feature types and the relationships to one another. I would like to emphasize that Highways is a relational product, and therefore each feature will interact with each other. For example, the road link will be referenced topologically by the road nodes. That is, it will reference the start node and end node of the road. You then have also the road and the street features, which both reference the road links. Then you also have the road junction in there, which will reference the road nodes, and the Ferry Network as well. However, we will go into more detail in the following slides for each feature. So also in the introduction, I would like to mention the common attributes you will find across all feature types in the Highways product, and many of them have been inherited from the inspired transport network model. And it will have attributes such as you can see on the slide, the GML ID, which is an important attribute, as this is the identifier of each feature. It will tell you if it comes from OS, and then you will have a TOID, OSGB followed by 16 digits. Or if it comes from the MSG, you will have a USRN, followed by 8 digits. Again, this is the identifier which will help you relate features to each other. You then also have an additional identifier, which is the actual identifier attribute. This comprises of a code base, and we'll also have the URL representing the ID. This will be without the prefix that you find in the GML ID, so without the USRN and the OSGB. The final identifier is the Inspire ID, which comprises of a local ID, again without the prefix such as the OSGB or USRN, and we'll also have a namespace, which will be Ordnance survey. We then also have, as you can see on the screen on the top right, some lifecycle information attribution, and the primary one I would like to emphasize is begin lifespan version, which tells you that whenever a new version of the feature exists in the product, this date will be updated with the publication date of that feature. The begin lifespan version is generally used for a supplying change-only update, which would be a feature in the feature release. You then also get some additional lifecycle information, which is valid from and valid to. These attributes are talking about the feature in relative terms of the actual real world. So this is not when the data changed, but when the feature is starting to exist in the real world. An example for that would be, for example, a street feature, which was it would tell you when it was actually built. So we are only populating for street, but that's the life cycle information. Also, another common attribute across all feature would be reason for change attribute, which tells you if it's, for example, a new feature has been added, or if you have modified geometry, modified attributes, or if you have modified geometry and attributes, or if it's an end of life for the specific feature and it has been removed from the Ordnance Survey master database. Again, this is used in change-only update orders. So that's, to conclude, that's the common attribute common attribution for all the features across highways and roads, and also the other products. But to kick things on, I would like to start with the first feature, the road link feature, and I will hand it over to my colleague Phil, who will explain a bit more on it. So over to you, Phil.
Thank you, Diana. Yes, welcome everybody. We're going to start with the road link, and I'm going to cover the road link and the road node separately, but they sort of belong together, and it's important to understand that the basic geometry of the entire network is based on those two features. So you have the nodes that provide the connecting points and the links that provide the connecting lines, basically. The connection between the nodes of road links are referenced within the road link feature through the start node and end node. So within each link, you will know which nodes actually connect to this link, or which nodes the link connects rather. We split road links for connectivity purposes. So we split them, for example, at junctions, or where we have to facilitate what we call grade separations. So where a road runs under a bridge or over a bridge, for example. You have a picture on the right on your screen at the moment, and it should be fairly clear to see that you've got two roads running above each other. And here we would have we would have a node where these roads cross. It's obviously not a connecting node because the two roads don't physically connect, but we would reference one as having a different grade separation to the other, just so you know they're running at different levels. We match the road link geometry to the National Street Gazetteer, and effectively the road link geometry is OS road geometry, so it's our own survey data, but we match that against the National Street Gazetteer to then get additional attribution. The geometry of the road link is a three-dimensional line, so you will have an actual height attribute with it as well. In terms of the attribution that we provide, there are a bunch of mandatory attributes and a bunch of optional attributes, which I'll go through in sequence now. And although some of the optional attributes are strictly optional, they are, in a sense, mandatory when certain things happen in the mandatory attributes when certain values are set. I'll try and explain that as best as I can, but if you look at the technical specification on page 15, you have a diagram that actually sets that out as well, so that's possibly slightly easier to understand if you're not already looking at it already. The first mandatory attribute we have is fictitious, and fictitious is a true and false Boolean indicator that shows whether the supplied geometry is indicative of a connection or an actual survey geometry. So it's not to say that the geometry is false or that it's fictitious and we made it up. It's purely to say that we might have not been able to actually find a connection, for example, from aerial imagery, and we had to make a connecting link at that point. We then have the start grade separation and end grade separation. These are linked directly to the grade separation already explained. So that should be fairly self-explanatory at this point, but in the picture example we have, the top road, for example, would have, or the top road link would have a start grade separation of 1 and 1, and the bottom one, for example, would have 0 and 0. So it just gives you an idea that they are separated at that point. The form of way describes the type of the carriageway, or in other words, what form does the road link take on the ground. So, for example, is it a dual carriageway? Is it a single carriageway? Is it a lay-by? And various other values, as you can see in the specification. We provide a provenance attribute. The provenance gives the capture accuracy of the height value within the link. So purely related to the height attribution, not to the actual spatial attribution otherwise. And here, this can be various, again, best to look at the specification for it. But very broadly speaking, it depends whether we've captured it in an urban environment or a rural or moorland environment. We provide a match status, and the match status indicates whether the road link has been matched against the feature in the International Street Gazetteer. So this will tell you whether we have actually managed to match it in the first place. We provide a length value, which is fairly self-explanatory, is the length of the road link in meters. We also provide a road classification, and this is a high-level classification of the road link, which identifies its officially designated importance and expected usage. So, for example, is it a motorway, is it an A road, or is it a classified unnumbered road, for example? Again, there are multiple values that can be, again, you can find those in the technical specification as a full list. Alongside the road classification, we also provide a route hierarchy. And the route hierarchy is a lower level classification of the road link, which gives a little bit more granular detail. And here, motorway would still be a motorway, but for example, A road would be split down in A road and A road primary. So giving a little bit more information about what the road actually is. We provide a couple of Boolean values, so again, true or false indicators, namely trunk road, which indicates whether the road link forms part of the trunk road network, and primary route, which indicates whether the road link forms part of the primary route network. We also provide an operational state, and this, in very simple terms, says whether the road is open, closed, or planned. And again, there are multiple values which you can see in the technical specification, but for example, one of them is under construction, so they are fairly self-explanatory. We also provide a mandatory directionality attribute, and directionality gives an indication of the direction of traffic flow along the link relative to the digitizing direction. It's a bit of a mouthful, the digitizing direction of the road link can be identified from the order of the coordinates, and it's important to understand that it's in relation to the digitizing direction, because where road link says, or directionality says both directions will count. But otherwise, we will say in direction or in opposite direction. And again, that is relevant to that digitizing direction. So potentially you could have a one-way street formed of multiple road links where the digitizing direction changes constantly, potentially. So you would have that change in direction, opposite direction constantly. So to understand that it's the digitizing direction that's important makes understanding the data at that point a little bit easier. So those are all the mandatory attributes. They're the ones we always provide. We then also have a bunch of optional attributes. And here we provide a few that are based on what the actual road is. So, for example, if the road classification is motorway, A road, or B road, then we will always populate the road classification number, since all A roads, B roads, and motorways in the UK will have a number with them. And the road classification number in this case is the officially assigned road classification numbers provided by the appropriate authority. And this will also always include at least one letter, so for example, A3, B203, etc., etc. We will provide a road name in the road link as well, which is a localized name string, and where more than one is given, the language identifier is provided as a 3-letter ISO code as well. And the road name is populated with the name from the street where street type is designated street name. We also provide an alternate name. We also provide an alternate name, which is a localized string, again, and this is populated from the road name. We provide an alternate identifier, and this is the identifier of the matched elementary street units from the National Street Gazetteer or the Trunk Road Street Gazetteer. We may, again, these are all optional attributes, we may provide a road structure, and here, although there are 2 values it could be, at the moment only road in tunnel would be populated if it applies, and it identifies whether the road link passes through a tunnel in this case. We provide a cycle facility attribute, which identifies whether the road link has facilities for cyclists, although again, only unknown type of cycle route along footway is populated, and that is only sparingly populated, so it will improve as time goes on, but at the moment it's not fully populated. We provide a road width value, and road width is an indication of the width of the road carriageway as recorded in the OS MasterMap topography layer. And it's important that this is an indicative width only, and it must not be used to identify whether individual vehicles are able to use the route. So it's an indication, it's not an absolute. We also provide an elevation gain attribute, and the elevation gain will give the elevation gain along the road link in meters, provided both in direction and against direction. And again, you can probably guess that this is to do with the direction of the digitizing. So not necessarily the driving direction of the route, but the order of the coordinates that the link is shown as. Finally, we provide for what we call associations, and they are effectively links to other things within the network. One of them being the start node, the other one being the end node. As said there, the nodes coinciding with the first and the last vertex of the road link, so the start and the end points. We provide a forms part of association, and these will be the identifiers of the roads or the streets that the road link forms part of. So if the road link is part of a road or a street in the network, those will be identified in here. And we also provide a link to the related road area, and this is an OS MasterMap topo GML ID of the relevant topographic area covering the road link. That's it for the road link. The road link is quite a big piece because we're covering quite a lot of information within it. And combined with the road node, it gives them almost the majority of the information in the network. The road node is a little bit lighter. We don't carry quite as much information on it. And as said, the road node provides the connecting grades within the network, but also potentially arbitrary grades, so where we have grade separation, they're not actually connecting. We split the network where an attribute changes, an intersection or a crossing of road links occurs, or where the road link starts or ends. The geometry of the road node is a point geometry, and the only mandatory attribute on the road node is the form of road node value, which is a description of the node function within the network. So for example, junction, where more than 2 links connect, pseudo node, where only 2 links connect, road end, where only 1 links connect, and a few other self-explanatory ones such as level crossing. In terms of optional attributions, we provide a classification, and this provides a little bit more of a further specialization of the form of road node value that was given. So for example, a pseudo node here could be given a grade separation classification, or for example, a mini roundabout, and there are a few others as well. We provide a junction name where the node forms part of a junction, and this is the name of any junction a node forms part of, again in a localized character string. So if there's more than one name, so for example Welsh and an English name, we will provide both, and we will provide the localized 3-digit ISO code with it. We also provide the junction number where the number of a motorway junction, for example, is given, and for an example, this could be the M5 junction 29. And finally, we also provide an association, and the association is the related road area, and this is again a OS MasterMap topo GML ID of the relevant topographic area that covers this road node. I know that's a lot to take in. Hopefully that clears it up a little bit what the road links and the road nodes are, and it will become clearer when Diana now goes back and talks about the road and the street, so what connects all of that together and makes it usable.
Yeah.
Over to you.
Thank you, Phil. So we will start now with the roads. As Phil said, the road feature is basically a link which represents a collection of road link features, and it's used primarily for vehicles that for motorized vehicles that share the same name. So name roads and classification numbers. A road, for example, reference the complete collection of road links features. irrespective of which authority boundary it falls within. And again, the feature will include motorways, A roads, B roads, name roads, and so on. But just to clarify as well, I would like to emphasize that road features will be derived from named roads within OS roads data. And again, it will not split according to authority boundaries. And also, as I just mentioned, road links can be referenced by multiple roads. So is this interaction, this relationship between the road links and roads. But just to, you can see an example as well on the screen with an A road, 830 on the screen, and a couple of attributes. But just to deep dive a bit more on the attribution side as well. Basically, in terms of attribution, besides the normal identifiers which you find and the common attributes you find in each feature type, you have the local road code, for example, which should give you an identification code assigned to the road by the local road authority. You also have the national road code, and when you have a national number of the road. And of course, the road classification, which should represent the national classification of the road, and it will include values such as motorway, A road, B road, classified and numbered, unclassified, and so on. In terms of the classification as well, we have a very good connection between the classification and attributes such as designated name. The designated name attribute is the official name assigned to the highway by a designated strict naming authority. On the road feature, this will always be the OS name. This is, it can have also sub-attributes, so the name under designated name will be the official name assigned to the highway, and then the naming of, and it can also be a different type of languages, so it can be English, Welsh, or Gaelic. The naming authority attribute will contain the local authority that assigned that designated name. Also, under a road feature, you have the link attribute, which should help you relate to the road links features. So we'll give you the reference, the toids to the road link feature, which build up the road feature. And that is basically the road attribution. Further on, a bit more complex attribution we have is for street feature. The street feature, as you can see an example now on the screen, basically extends and specializes more on what is on the road feature, and can represent a road or a track. A street feature will split when it crosses the boundary of an administrative area, so where the local maintenance responsibility changes. A street can also split, as you can see in the example, the orange dotted line, which splits according to a boundary. So it can also split at a town or a locality boundary, to allow property to be located uniquely upon a street by a geographic identifier, an USRN, as you may know. Also, I would like to emphasize the way the street feature is generated. So it's populated from the National Street Gazetteer and will exist regardless of whether an elementary street unit geometry has been matched to at least one of the road links. Therefore, the street geometry is basically an aggregated geometry. So if any of the streets, elementary street units have been matched to a road link, then the aggregated geometry of the road links will be provided. However, if none of the streets have been matched road links, so the ESU if they haven't been matched, then the aggregated geometry of the elementary street units will be provided, so the energy geometry. The provenance of this geometry can be identified through the geometry provenance attribute, and they will represent either the complete street or a section of that street within an administrative unit, town, or locality. Also, a road link can be referenced by multiple street features. So we have that relationship again with a road link. But just to discuss now a bit more on the attribution, I will start with the next slide, where you can see the diagram, which you can find in the technical specification document as well. In there, you will see basically the mandatory but also the optional attribute and the code list type of values with blue boxes, and then with orange you can see the actual attributes. So as I said earlier, the street is in the same way as the road is basically a table and database which relates back to the road links. And in terms of constraints, which you should be aware of for the street feature, the street feature has classification, as you can see on the screen in the attributes, and the classification type is very much related to the structure. So it should only have one of the designated name type 1, descriptor type 2, national road code type 3, local road code, which is type 3 as well, or the local name type 4. So for example, just to explain this a bit more, if a street has a descriptor, it shall not have a designated name. Also, another important constraint to mention, if geometry provenance does not equal Ordnance survey, then the link attribute shall be null. And then if the road classification on the other side, it's motorway or A road or B road, then subsequently the national road code shall not be null. Again, the road link geometry, I would emphasize it's OS geometry, and it will be the same as in ITN. However, when it comes to street features, we have a different situation. In the attribute of street feature, there is the provenance attribute, again, which will help you identify where the geometry has been sourced from. But the street geometry could be either aggregated OS geometry or aggregated NSG geometry. It all depends if we've been able to match the road link to an elementary street unit. Then the street will have the geometry of road links features from OS. However, if we have not been able to provide a match to the street feature to the USRN, then the geometry provided for that feature will be aggregated elementary street units, which make up the USRN from the NSG. But coming back again to the other attribution, so just to go a bit more into more detail onto the local road code. As I said, the street type directly relates to the classification. So the blue box you see there, the street type value, where you have designated street name, that's a type 1, which relates back to the designated name. So if you have a street with a designated name, then you will have the designated street name as populated. Then if you have an officially described street, you will have the descriptor populated. On the other hand, if you have an unofficial street name, you will have the local name populated, and so on. So that's the relationship you need to be aware of in terms of the population of the attributes. It all depends on the classification. The local road code can only be used for classified and numbered roads, and it tells you the identification code assigned to the road by the local road authority. The national road code is the national number of the road. So if you have A road or B road, the national road code should not be null, should be populated. Designated name, as we discussed a bit earlier, it tells you the official name assigned to the highway by the street naming authority is the same as with roads. It has two attributes, one for name, which is the official name assigned to the highway, and it can be provided in 3 different languages, English, Welsh, and Gaelic. And then you have the naming authority. And then to move on, the other attribute is local name. which is an unofficial local name associated to the highway. Again, this is provided as a 3-digit ISO code as well for the 3 languages. Descriptor, it's basically the street description allocated by a street naming authority or highway authority used to identify a street that does not have a designated name. So again, if you have this, the designated name won't be populated, however, a descriptor will be. This is similarly a 3-digit provided as a 3-digit ISO code name for the 3 English or Welsh or Gaelic, sorry. You also have road classification attribute, which provides you the national classification of the road. As you may know, the code list contains motorway, A road, B road, and so on. You can find that in more detail in the technical specification document. And the very important attribute, which I kept saying about the street type, which again relates to all the other attributes, and is the classification of the type of street from the National Street Gazetteer. And finally, an operational state attribute, which should give you an indication if there is a physical aspect on the nature of the road, if it's under construction or if it's open, or if it's temporarily closed. You will have this information populated in operational state attribute. Locality represents the populated place, representing the locality that the street is located within. Again, you'll have this provided as a 3-digit ISO code. Town attribute provides you the settlement that the street falls within, as well a 3-digit ISO code code list populated here. Administrative area is basically where the street is located within. It's providing you, again, the information in a 3-digit ISO code name. The responsible authority should give you the reference to the authority that has the responsibility for naming and numbering that street. Geometry provenance, as we've just discussed, will be able to identify where the geometry of the feature originated from. The geometry attribute is basically the aggregated geometry of either the matched road links or the matched or the unmatched elementary street units. The GSS code, finally, it's also an attribute found at street level, and it gives you a reference to the unique identifier of administrative areas managed by the Office for National Statistics, ONS. So the role is used to describe the authority, whether it's an upper tier local authority, lower tier local authority, or maybe unitary local authority. And you also have the link attribution, which is a voidable attribution, as we saw a bit earlier in the constraint. If there is a constraint related to the link, so the link should also give you the reference to the road link feature, which build up the street feature. So wherever a street has not been matched for road link, this attribute will be voided. So that was the connection when this attribute is voided. If the street has not been matched to OS geometry, then this attribute is voided. So again, this is one lengthy feature as well to discuss about attribution. However, it's a very important one because I know this has been very technical to explain, but I do have some examples which might actually make it a bit more clear. In this slide, you can see now a road with a numbered example that gives you basically the collection of road link features that make up the A41 road. On the other hand, in the next slide, you will see for the same area and the same situation, the street feature, where you have actually two elements, two street features for that the same A41 area. You have actually two street features, one for authority A on the left side and one for authority B on the right side. So street features, again, take into account administrative boundaries, and you should have the split in your data. Another example which might help illustrate the role and the difference between road and street. With road, again, you have two features in this example, and they reference individually named parts, and you have two elements, one on the left side for Bliston Road, and then on the right side you have Wellington Road. However, when it comes to the street feature in this slide, for the same area, you can see you actually have three features. So you have three street features. You have one on the left with the red polygon, which represents the Bliston Road, and then on the right side, where you have the administrative boundary with orange, you have two features. One is for authority A, and then the other is for authority B. So again, I hope this helps illustrate as well the difference between road and street and how they manifest in the data. But further on, after finishing these two lengthy and important features in our highways road product, I would like to hand it back to Phil to discuss a bit more as well on the road junction feature, which is again a new type of feature as a structure and content. So over to you, Phil.
Thank you. Yes, so the road junction is one of those small hidden little things that are in highways that make it stand out from the old ITN offering quite a bit. One of the bits of feedback we always had was that it's difficult to define which points or which nodes and which links belong to a junction, and to actually conduct proper analysis on them or use them properly. So the road junction feature enables easier querying of road junctions compared to ITN, as it shows the collection of all road node features that share the same road junction name or number. Now this includes all nodes that make up slip roads and any other connecting links between two or more crossing road features. It's important to note that pseudo nodes would not be covered. And if you look at the example on the screen, hopefully you can just about make up the top picture. You would see a bunch of sort of turquoise highlighted points. Now these would be included in the junction because they're actually part of the slip road infrastructure. However, the red dots where the roads clearly cross, they're purely there for grade separation, which I mentioned earlier, and therefore they don't actually belong to the junction. They're just there to indicate, look, there are two roads actually running above each other, but they're not connecting at that specific point. Road nodes can be referenced by multiple road junction features, and to illustrate that, think of a motorway junction where two major motorways cross. You would, for example, have the M4 junction, let's just say junction 3 is escaping which one crosses with the M25, but on the M25 that would not be junction 3, that would be junction 10 or 11 or whichever one it is. But because of that, the same nodes would be referenced by two separate road junction features. Motorway junctions at the moment are fully populated, and other junctions are being added as data is improved and we get more information on this. Unlike the road links and the road nodes, road junctions do not provide their own geometry. However, this is inferred from the collection of the road nodes that make up the feature. So we provide the nodes, and from the nodes we then have the geometry. In terms of the mandatory attributes, we provide a junction type, and the junction type will either be named junction, numbered A road junction, or numbered motorway junction. We also provide a junction name, and we provide this regardless of the junction type. It's only the content that changes in this case. And the junction name will be the name of the junction if it is a named junction. And if it's a numbered junction, then it will give a full reference. So for example, M5 junction 29, as you can see on the screen there. We also provide a optional attribute, and this would be the road classification number, which is the official road number as assigned by the relevant authority, if there is a road number that is to be assigned. So for example, M5 in the example we've just seen. And we also provide the junction number, and this will be the number of the junction. So for example, 9 or for example, 10A, so it could have a letter in it where there is an actual junction number there. We then also provide the association of all nodes, and this is just a list of all the nodes that reference the road junction. Sorry, a list of all road nodes that make up the road junction, so that are referenced by the road junction. And that concludes the actual road part and the sort of surface part of the network. And I'll hand you back to Diana now for the water-based aspects of the network, so the ferry aspect. So over to you.
Thank you, Phil. So now we will be discussing the ferry network. As you can see now on the screen, you have the diagram, which you can also find at page 34 in the road's technical specification document. And it just shows you how the ferry link, ferry node, and ferry terminal are attributed. And also, I would like to mention some of the attributes that have been inherited from the Inspire model. And it will be held on these features, and it allows them to relate to each other as well as to the other features in the roads product. But to keep things on, I would like to start with the ferry link feature. The ferry link represents a network link for routes for a vehicular or pedestrian ferry route. In terms of attribution for the ferry link, you have the normal common attributes, and then you have attributions such as center line geometry, which should give you the geometry, the three-dimensional geometry that represents the connection between the ferry terminals. Where detail alignment is provided, it is only an indication of the route a vessel would take, and the third dimension is only provided for connectivity, and it does not reflect the actual real world in general. That is why we also have the fictitious attribute, which should give you the indication that the center line geometry of the link is just a straight line with no intermediate control points, unless there is the straight line actually represents the geography, the resolution of the data set appropriately. We're actually investigating to see if we can populate the geometry with actual more structured, topologically structured geometry. We've started looking at that. However, it will be ongoing work for the ferry links. But moving on to the other attributes, we have vehicular ferry, which is an indicator if this ferry link represents a ferry that can be used by vehicles. This will always be set to, I believe, it will be set to true in the roads product. Start node, you have the node coincident with the first vertex of the geometry attribute. And then you also have the end node, which should give you the reference to the node that is coincident with the last vertex of the geometry attribute. And that's basically the attribution for the ferry link. Also, on this page, on this slide, you can see the ferry node, which has quite a simple attribution, and it represents basically the feature that shows the point at which the vehicular or the pedestrian ferry routes or section of the ferry route start or end. So in a way, this shows is used to represent the connectivity where the ferry link feature starts or ends. Also, the ferry node feature may serve multiple ferry link features if more than one destination is served from the same location. Ferry nodes will always be referenced by at least one ferry link, therefore. As attribution, you have the geometry, which should give you the location of the node. And also you have the form of waterway node attribution, which gives you the description of the function of the waterway node in the water transport network. The form of waterway node value can also be found at page 45 in the technical specification document. And it basically has a code called water terminal, which is basically the location where goods are transported. This is inherited from the Inspire, and it's not extendable. Further on, we have the ferry terminal attribution. You can see on the screen as well. The ferry and the road network elements are linked together through the ferry terminal feature. A ferry terminal is just a logical connection between the two networks, and therefore there's no actual geometry supplied with these features. They will reference one road node and one ferry node. The ferry terminals will also provide a reference to the OS MasterMap site feature. In terms of attribution for it, you will find the type attribute, which has a categorization of the network connection, and the type of values populated here. You can find them at page 45 in the technical spec document as well. This is another code that has been inspired from, has been inherited from the Inspire initiative, and is not extendable. And the value which you will find populated in here is intermodal, and it should give you an indication that the connection between the two network elements in different transport networks that are using a different transport mode, the connection basically represents a possibility for the transported media, whether it's people or goods, to change from one type of transport to another. So that's the role of this value. Then you also have the reference to functional site attribution, as I've just mentioned earlier, which should give you the reference to the site representation of the ferry terminal in the OS MasterMap sites layer. So again, a connection to one of our products as well. You have also another attribution called element, which is giving you the reference to the road node, or the road node and the ferry node. So the type of node that the element is referencing will be identified through a link type of reference. So that's the ferry network and the roads product. And with this, I will conclude all the features in the roads product. And also, you have now, just to illustrate the connection between the features, you have now the roads relational model on the screen. Again, this illustrates how they interact with each other. The attribute at the arrowhead is the primary key, whereas the attribute at the base of the arrow is the actual foreign key. So if you're building any modeling or doing the network, you should be aware of these connections between the features. So for example, to explain this a bit more, the road link is topologically referenced by the road nodes through start node and end node. Therefore, the foreign keys will be start node and end nodes, which are road link feature attributes, whereas the primary keys are the actual IDs of the road node feature. So that's how they interact, and you can link between them, you can relate them to one another. And you can see also with the green boxes, you can see the reference we have to the other products, to the other OS products. So you have the topo area, which links it back to the topographic OS product. And you also have the functional site referencing back to our OS sites, MasterMap sites product. So that's the roads, highways, roads product. Go into a deep dive explanation, and we are now happy to take any questions you have.